All right, 6-3, adding and subtracting rational expressions. Lance, what do you know about adding fractions? What has to be the same? Denominator. This is why I wanted to break this up, because making the denominator the same is kind of like a pain. It's a pain for normal fractions, so it's even going to be worse for this, okay? So to add two fractions, like 1/5 and 2/5, that's easy. They have common denominators. I just add the numerator, right? So I would do 1 + 2 is 3, and I get 3/5, okay? But the problem becomes, well, how do I add fractions that have unlike denominators, like 1/8 and 1/16? Well, the thing is you have to make the 1/8 have the same denominator as the 1/16. So that would be 16. So how do I make 1/8 into something over 16? So I would multiply it by 2, and I would get 2/16 plus 1/16 is 3/16. Kind of makes sense to you guys? Okay. So for these first couple, they're pretty straightforward. Notice they all have like denominators. The only thing we have to pay attention to is reducing. Okay? Just like a normal fraction, if we had, say, all right, let's do 8s. If we have 3/8 plus 3/8, right? That would be 6/8. But then you wouldn't leave your answer as 6/8. You would have to reduce that to 2, or what is it? 3/4. So here, what I need to do is I have 4/3x plus 5/3x. That's going to be 9/3x. But you can't leave it like that. I have to reduce it. The 9 and the 3 can be reduced. So 3 goes into 9 3 times. So my answer is 3/x. Carolina, are you okay with that? Not too tricky, right? All right. Over here, I have 2x/x plus 3 minus 4/x plus 3. They're both over x plus 3. So I can write it as 2x minus 4/x plus 3. Nothing I can do there. I can't combine the 2x and the 4. They're not like terms. There's nothing to be canceled. You guys try the bottom two. See what you can do. Lance, when do you have competitions? We'll do it. Thinking like, I was gonna do it, it's just really, there's no point. It's not like, we need to be fun. Like you'd be running, and I feel like if you hit that wind gust, you're just like, ooh. Chris, you done? What'd you get for number 1? So you got, okay, 9x/6 over 2. So it would simplify to 3x/2. Okay. Notice 3 goes into both 9 and 6. So I do 9 divided by 3 is 3. 6 divided by 3 is 2. All right. Julia, what'd you get for number 3?
C minus 1 and C squared plus 3C minus.
I think you did the wrong one.
Oh, for number 3. No,
Yeah.
I like 2B plus 3 over B squared minus 5B.
Now, Julia, I'm gonna ask you this. Are you sure that's the final answer?
Yeah.
Okay, how do you know it's the final answer? How do you know I can't reduce it? Okay, but the question becomes this, and you're right, Julia, you're not wrong. But the question becomes this. We've been learning how to factor, right? And that denominator certainly looks like it can be factored. Agreed?
Oh,
All right. Can I factor -12, okay, to come up with -5? Right? That's what it's going to become. That's what you're going to have to ask yourself. Am I able to factor -12 such that I can get -5? And is there a way? No, we have 1 and 12 that either gives you 11 or 13. Okay. And then you have 2 and 6, that's either 8 or 4. And then 3 and 4 either gives you what? 7 or 1, right? So the answer to this is yeah, that's in reduced form. Like I can't simplify that anymore. Okay. And then we have number 2. Jake, did you want to answer number 2?
Sure.
Okay. What do you got, Jake?
Well, I think first we would add the one at C, right?
Okay. So what does that give me? It says C over C squared plus 3C minus 4 minus 1 over C squared plus 3C minus 4.
Would be C minus 1
C minus 1 over
over,
C squared plus 3C minus 4. Is
yeah,
that what you're saying? Okay. Now, am I done? No. Why am I not done? Hannah,
Yeah,
Hannah, can we factor C squared plus 3C minus 4? Don't worry about the numerator. Can I factor the denominator?
yeah,
What are the factors of -4 that add up to 3?
3 and -1 or 3, -3 and 1.
But remember, it has to add up to what?
Oh, so -3 and -1.
Well, it also has to multiply to give me 4, right? So would it be C plus 4 times C minus 1? Does that work?
Yeah,
Okay. 4 times -1 is -4. 4 plus -1 is 3. But now, on top of that C minus 1, right, Jake? What's the same on top and bottom?
C minus 1.
So the whole point of this is when I add these fractions, okay, or subtract them, I'm going to get a rational expression. I'm going to have to check to see if I can factor the numerator and the denominator and see if I can cancel anything to give it to me in a simplified form. Okay. Like the one Julia did, number 3, I couldn't. I couldn't factor. It was done. We talked about it. We couldn't do it. But number 2, I could factor it. So once I factored it, I would have to cancel out those like terms and then give it to me in a reduced form, which was 1 over C plus 4. You guys okay with that?
I don't think- the bottom part you did that. Oh, the-
Yeah, I asked myself, what are the factors of -4 that add up to 3?
Oh, okay.
Okay. So I just factored it.
Yeah, that-
Okay, I didn't use the British method, I just factored. Now this is where it gets tricky. You ready for it, Chris? All right, 6 and 8. Okay, it's really where this problem starts. Why am I picking on 6 and 8? Because that's what's different. Notice both of these fractions have an x. That's the same. I'm okay with that because it's the same. But the 6 and 8 are different. How can I make 6 and 8 be the same number? Add. Add.
Yeah,
What number does 6 and 8 both go into?
2.
Now, 2 goes into both of them. But what number is divisible by 6 and by 8?
Uh,
So it's bigger than 8.
oh, okay. 16.
Does 6 go into 16?
Yeah, no.
No. Do you want some help?
No.
Okay. So what number goes into 6 and 8? Or not, what number goes into 6 and 8? What number does 6 and 8 both go into?
I don't know.
Will do. Still with me, Ed?
Yeah.
Any updates for me?
No.
Okay. Jake? 24. Both 6 and 8 both go into 24. So my common denominator is going to be 24x. They both share the x, but the 6 and the 8, they're both the same with 24. So how do I make 6 equal to 24? Well, I'm going to multiply that by 4 over 4. Okay? I don't have to deal with the x because that's already there. It's already part of both denominators. In the other piece, how am I going to make an 8 to 24? Well, I'm going to multiply it by 3 over 3. 4 times 7 is 28. 4 times 6x is 24x. Plus 5 times 3 is 15. 8x times 3 is 24x. Mike, are my denominators the same now? So I can just do 28 plus 15, right? 28 plus 15 is 43 over 24x. Can I reduce 43 over 24x? Lance, what do you think? Yep. Okay, you can. All right. Let's talk about B. Kaylin, are these the same? No, they're very different, right? Now, the difference between B and A is this. In A, we have multiplication, right? So they both share, both had an x, right? Now, I know in B, they also have an x, right, Kaylin? But the difference with B is the plus and minus. So that's a whole thing. It's like one piece. So when we're looking at B, all right, I'm just going to rewrite it here so I have some room to work. When I'm looking at B, what is in this, I guess, the rational expression to the right that's not there on the left? Well, that is the x plus 2. Notice on the left, the denominator has an x minus 3, but it was missing that x plus 2. Do you guys see that? Now on the right, what's missing? Well, I have the x plus 2, but I'm missing x minus 3. So I'm going to make the common denominator by multiplying by the expression that's missing. All right, on the left, I had x minus 3, so I multiply by x plus 2. On the right, I have an x plus 2, so I multiply by x minus 3. Does that kind of make sense to you? Just a little bit. Now, the nice part about this, you ready for it, Caleb? We don't want to multiply these out. I don't want to multiply the denominators out. I want to wait. So I will multiply the numerators out. So I'm going to do 3 times x is 3x. 3 times 2 is 6 minus, okay? 5 times x is 5x. 5 times -3 is -15. And this is all over x plus 2 times x minus 3. Now, the reason why I left this without foiling it is if I were to foil it, well, then what happens on the next step if I need to cancel? I have to undo that work, right? So I'm going to leave it here because once I simplify the numerator, okay, 3x minus 5x is -2x. 6 minus -15 is 21. If I were able to cancel anything, it'd be easier to cancel it. What's that? 3x minus 5x, Jake. 6 minus -15. Okay?
And then at the top, you do, like, give the 3 times 2, like, -3 times 2, right?
Yeah. Okay. Do you guys see where I got that from? Like I'm trying to not bore you, but I'm also trying to take it slow so that we don't have to go back and redo it. Okay. So one more time. I started with this whole expression, adding rational expressions. I looked at the denominators. I saw what was different. Okay, the one on the left was missing x plus 2. The one on the right was missing x minus 3. So I multiplied by that. I didn't multiply out the denominator because if I have to cancel, it's going to be easier for me to cancel with it unfactored. I'm going to be able to see that easier. So I kept it unfoiled. The numerators, I distributed 3 to the x plus 2 and the 5 to the x minus 3. It said to subtract the 2. So I subtracted the 2 expressions in the numerator. That gave me -2x plus 21. If I could factor that, I would. But I can't. There's nothing else I can do. So I'd leave it like this. Couple things. One, I can see where my domain is, right? If I asked you, hey, what's my domain? You could say all real numbers except for x equals -2 and x equals 3. You could see that easily. All right. So a lot of benefits to that. All right, let's look at C. All right, if you guys get confused, just stop, ask a question, okay? You okay with that, Chris? Gotcha. All right. You can bet on me, don't bet on Villanova. Okay, here we go. First thing I'm going to do, I'm just going to start out by rewrite. Let me give myself some more space. Rewriting my problem. I'm not doing anything. I just need some space. All right. Here's what we're going to do. Watch. Just soak it in. And then I'll give you guys like a moment and we'll go back through. Okay. Here we go. I need to find out what's different between the two sides. Okay. We got a lot going on here. On the left, I got a 6x squared. On the right, I have 4x squared minus 12x. They look very different. Could I multiply the left by 4x squared minus 12x and the right by 6x squared? Yeah, I could. But I'm gonna have to like reduce towards the end. I'm gonna get a lot of ugly stuff. So here's what you want to do. Okay, you want to factor whatever you can to see what's different. So on the left here, or on the right, notice it's 4x squared minus 12x. So what I'm going to do is I'm going to factor out the greatest common factor of 4 and x, because they both share an x and 4 goes into both of them. So 4x squared divided by 4x is x. Negative 12x divided by 4x is negative 3. Does everybody see that? Now, do we see how there's an x on top and an x on bottom? Well, can I cancel them? So I'm going to cancel these. That leaves me with 1 over 4 times x minus 3. Now, on the left, not much I can factor, right? Pretty much already broken down for me. So this problem's really asking me to add 5 over 6x squared plus 1 over 4 times the quantity of x minus 3. So this is where the problem starts. What's different between the right and the left? Well, on the right, I have a 4 and an x minus 3. So I'm thinking 6 and 4, how can I make them the same? Well, I can make them the same by multiplying 6 by 2 to make it equal to 12, and 4 by 3 to make it equal to 12 as well. Now, this one on the right, well, it has an x minus 3. The one on the left does not. So I'm going to multiply it by x minus 3. Hold on. Now, on the right, notice, okay, I have an x minus 3, but it's missing this x squared. So I'm going to multiply by x squared. Now my denominator. Let's talk about this. 2 times 6 is 12. 4 times 3 is 12. They both have 12. They're both going to have x squareds. Okay? The one on the left had it there. The one on the right, I added it. They're both going to have x minus 3. I added it on the left. The one on the right had it. Do we all see that? So my denominator is going to be kind of big, but there's a lot going on. All right. So on the left, I'm going to multiply everything by 5, okay, and 2. So I'm going to have 5 times 2, that's 10. So I'm going to distribute the 10 into the x minus 3. 10 times x is 10x. 10 times 3 is negative 30. Plus, because we're adding the two expressions. 1 times 3, 3x squared is just 3x squared. And that's all I have there. On bottom, right, we have the 12 we talked about. We have the x squared. And we have x minus 3. Okay? Do you guys see that? And then from there, I would see if I could factor it any further. But we're going to stop there and we're going to start it over again. Jake. Jake, right here. I'm going to go over it again. Okay? You guys okay with it? Here we go. Now that you saw the end game, right? Here we go. Here's what we got to do. We have to make the denominators the same. So what I like to do first is I like to see what are my different components of the denominator. I have numbers, I have x's, and then I'm going to have like an expression. So what I like to do is I like to factor this over here to just see what's different, the different pieces. So did everybody write that? Did we all write that now? Now, once I've written that, the only thing I can factor is the piece on the right. Numerator, you can't factor. Denominator, I can take out a 4x. That leaves me with x minus 3. You okay with that, Julia? Now I have 3 different components of the denominator. I have numbers, I have these x's outside, and then I have what's inside the parentheses, the x minus 3. So my denominator needs to have 3 pieces. It needs to have a number that's the same, needs to have x's that are the same, and the expression piece, that x minus 3 piece. So over here, okay, I can cancel these out. It's going to help me a little bit. Okay, so on the left, what's missing? Well, 6 and 4 aren't the same. I need to make them the same. The number they would be the same at is 12. So I have to make a 6 and 12. I do that by multiplying it by 2. Okay? On the right, I have a 4. I need to make that a 12. I multiply it by 3. We good so far? Now, x squared. Okay? Notice on the left, we have an x squared. On the right, there is none. Okay? So I'm going to have to multiply this piece on the right because it's missing the x squared. On the left, well, I have the x squared, but I'm missing this x minus 3. So I multiplied that, and now I have all the components. The numbers will be the same. They'll both be 12. 2 times 6 is 12. 4 times 3 is 12. They'll both have the x squared. This one on the left had it to start. The one on the right, I added it. On the left, we'll have the x minus 3 now because I added it, and it was already there on the right. So now I have to clean this up. So what I do, I have a 2 and a 5. That's 10. So I have 10 times x minus 3. 10 times x is 10x. 10 times negative 3 is negative 30. Plus, that's what's in the middle, the plus. I have 1 times 3x squared. And on bottom, okay, I'm going to combine my numbers. I have a 2 and a 6, that's 12. Okay, that was the number we were trying to get to. They both have x squared. And they both have the x minus 3. All right. And from there, which I know we're going to run out of time for, but we just clean that up by writing 3x squared plus 10x minus 30 over 12x squared times x minus 3. And what I would do from here is I would use the British method to see if I could factor out anything else. Jake. Because it was part of the common denominator. Yeah, it needs to be the same. Here? Well, because it's here, I can't add these two unless I put it over here.
Oh, so it's there and there.
Yeah, it has to be both places.
So,
All right.
so we went to both places.
I had to put it in both places. Okay,